Our team is called Try Forever. Trying forever, this is what we keep in mind. During the preparation for this competition, we will always try, innovate, and create better robots. Our robot is designed specifically for libraries. Our goal is to create a zero-touch library service with technology.
The robot that we use this time is based on the version from last year. This year, we designed and made most of our robot's parts all by ourselves while not using pre-made parts, so that we can improve our robot's design easier. We have also added some improver designs to it. The open manipulator of our robot this year has more room and space to move. Also, the height of the manipulator is just high enough to grab objects from tables, from a person sitting down, and from a person standing up in a comfortable position easily. The screen of our robot is also designed in a particular angle that people can see at the screen in a comfortable way. The robot is designed into a 6-layer cylinder shape. At the very bottom of our robot is the kabuki base, and above it is the OPL-11 laser range scan. At the third layer, we put an Intel NUC and 2 USB hubs, which connect different components inside our robots. There are 2 speakers on the next layer, and on the next layer is the open manipulator that the robot uses to grab small objects. See the emergency button there? When the button is pressed, the whole kabuki base stops running. On top of it sits an Astra camera. It can help the robot gather visual information of the environment around the robot. The re-speaker installed on the camera can accurately detect what people say to the robot when communicating with them. And above it is our screen and another Astra camera.
This year, compared to the last year, we have more functions.
There are 3 main functions we want to achieve this year, which are checking the health code, recording and controlling the number of people, and finding and returning books. To achieve these goals, we completed these 5 parts. 1. Deep Neural Network. This year, we improved our object detection method. Last year, we used color detection to target our objects. But the problem is, when the object is not specified, our robot cannot detect it. This year, we use deep neural networks to detect objects, which can detect objects more precisely and wisely. The object detection deep neural network we used are YOLO V5 and FastStar RCNN, which can recognize some common objects in daily life. For example, chairs, books, people, and bottles. Also, due to the epidemic of COVID-19, we made a DNN with PyTorch that recognizes the color of a health code to check the health status of visitors. The network is designed and trained by ourselves, and the dataset of health codes in different colors is also collected by us. 2. Camera. There are 2 main functions that are related to the camera in our programs. Capture the image. When the camera turns on, it will create a stream that sends raw images, subscribed by our core program. The raw images that the core program received will be converted into a CV2 format for further usages, like sending to neural networks. Calculate the coordinates of an object. we can calculate the real coordinates, whose origin point is the depth camera, of a point in depth image which the camera captured by this formula. 3. Robotic arm. The robotic arm on our robot is mainly for carrying things, such as bottles and books. There are 3 steps to grab a thing. 1. Find the object by neural networks. 2. Calculate the coordinates whose origin is the camera, and then convert the origin to the robotic arm. 3. Publish the coordinates to the robotic arm controller. Also, we found that there are some special cases which the robotic arm cannot move to a point directly. To solve this problem, we cut the path into slices and move step by step. 4. SLAM. SLAM SLAM, which is the short form of simultaneous localization and mapping, is important for a robot since it navigates the robot. Compared to the last year, this year we use LiDAR to do the mapping work, instead of an RGBD camera. The image here is the map mapped by RGBD camera, and the image here is mapped by LiDAR. Obviously, we can see that the one mapped by RGBD camera is very inaccurate. There are many nonsense areas and obstacles in the map. There are no configurations for LiDAR in the standard pack of TurtleBot 2, so in order to use the LiDAR, we rewrote the configure files specifically for LiDAR. Computers are no longer recognizing fixed keywords, but using natural language understanding engine to recognize sentences. It can understand the meaning of the sentence spoken by the user, and respond according to the meaning. We use the SNIFS NLU model, which can recognize the meaning of the sentence well. Through the NLU engine, the robot can recognize the meaning of a sentence from some utterance and collect additional field data if needed. The goal of entity extraction is to fill any holes needed to accomplish the task, while ignoring unneeded details. This is a process of subtraction, and the chatbot only gets the necessary information, whether it's provided by the user once or through a guided conversation with the chatbot. In order for NLU to work for a specific goal, it needs to predefine all types of entities and intents we want the bot to recognize.